Okay, this is your specimen. Now, if you notice, I have an arrow on it. That's the direction you have to load it into the machine every time, okay? Like I say, it has to go in the same way. So you're gonna place your specimen here. You're gonna take this stick. Here's your on and off. This is your on. That's your stop. This is your stop as well if you get hung up on this thing. You just kick it with your knee. Now the handle, if you set it up this way where this little deal is right there, and you go one full, you always go to the left. You don't want to come back. If you come back, you picked up the mechanical slack and the equipment. Then you don't know where you're at. So one full turn of this handle is 0.005. Okay? So let's just run it through and see what happens. Now, prior to this, we've already measured our specimen. It's about 1/4 inch thick. So what we're going to do is reduce it down to your first reduction rate. So I'm going to turn it on, push it through. Now it didn't make any noise, so we're going to take one full turn. Do it again. Still didn't do anything. Bring it down again. Can you hear that? Stop it. Now we want to take it back over the table and measure your specimen to see what thickness it is. And if it's at your target rate, then you need to go over to the hardness tester and do a hardness test on it, okay?
All right.
Okay, this is the co-working portion of the lab. This is your worksheet that you have for in your lab manual. So what you're going to end up doing is, let's say bar number 1, you're going to reduce down to 30% reduction. So what you do, you take your calipers, take one of your samples, and you need to file the edges just a little bit so you get an accurate reading. And you use a file in this direction. Okay? Do both sides. Get a measurement on your specimen. Okay, so you get your measurement. It should be right around 1/4 inch. Now, you're going to take the initial measurement of your bar and you're going to reduce it by 2%. And then you're going to take the original measurement of your bar again and measure it at 5% reduction, 10%, 20, and 30, and so on. So you go down to 30% reduction on the number 1 bar. The 2, 3, and 4 bars, you're going to reduce down to 60% reduction. So you're going to reduce down to 2% from the original thickness, the second 5% from the original thickness, and so on. Okay. Now, after each thickness reduction, you need to go do a hardness test. So before you even start, we're going to go do a hardness test on your specimens. And these are annealed samples. They were done here in the lab. So let's go get a measurement on the number 1 sample of the 260 brass. Okay, now I want you to do a hardness test on this annealed piece of brass. It's a 260 cartridge brass. So we've got our machine set up in HRVW scale. We've got the correct indenter placed in the machine. Now, I've annealed this material here in the lab and it is very soft. So let's just see what we get. I'm set up. This is going to be an unusual reading, okay? Now look what we're getting. A minus 4.9. Let's do another reading. That's telling me that I annealed this material so that it's very ductile. Again, we're getting a bad reading. Okay, I'm going to make one more. Okay, again, we're getting a bad reading again. So what we're saying is this material is very ductile. Now we're gonna go start to cold work it, and each time you find your reduction, you will come over and do a hardness test on it and document what your results are. Okay, after you've gotten to your reduction portion, which you also, if you look here, it tells you that 1 full turn on the rolling mill is 0.005. You do not want to go over more than 4 turns as you're reducing down in your thickness. If you do, I'm going to guarantee you it will eat this piece of brass. And you have to start over, because what you're going to do once you reach your reductions and did your hardness testing, you have to mark off 10 pieces, and we'll end up cutting these, okay, to put them into this. This is the annealing portion of this lab. So we need this for the annealing portion of the lab, and I'll guarantee if you fail, it's going to have to be redone. We need these parts for the second portion of the lab. That's it.